Let me take you back to a moment you've probably witnessed, maybe in a hospital room, maybe at home, where a loved one looks at you and for the first time doesn't recognize who you are. When we talk about the brain, we often think of it as separate from the rest of the body, an isolated control center, sitting safely inside the skull. But the truth is, the brain is deeply connected to every metabolic and inflammatory process happening throughout the body. One of the most critical and often overlooked contributors to cognitive decline and dementia is what we're eating on a daily basis. Not just occasionally, not just in excess, but as a regular part of the modern diet. And specifically, ultra-processed foods have emerged as one of the most damaging elements to brain health over time. These foods are everywhere. In fact, in many developed countries, they now make up more than 50% of daily calorie intake for the average person. We're talking about items that are high in refined sugars, artificial additives, preservatives, and particularly industrial seed oils, ingredients engineered for long shelf life and low cost, not for human physiology. When these foods are consumed regularly, they create an internal environment that is primed for metabolic dysfunction. The very systems that regulate energy, blood sugar, and inflammation start to break down, and the brain is not immune to these effects. Studies are now showing a clear and troubling connection between diets high in ultra-processed foods and accelerated cognitive decline. The mechanism is multifaceted, but much of it comes down to inflammation and insulin resistance. These processed products cause frequent spikes in blood glucose and insulin, and over time, the body becomes less sensitive to insulin's effects. When this happens in the brain, it impairs glucose uptake by neurons, essentially starving brain cells of the fuel they need to function. This is particularly damaging in areas like the hippocampus, which is responsible for memory formation and retrieval. But the problem doesn't stop at insulin. The chemical byproducts of ultra-processing, especially advanced glycation end products, AGs, and oxidized seed oils, initiate a cascade of inflammation in the brain. Microglia, the immune cells of the central nervous system, become chronically activated. And when inflammation becomes a chronic state, it begins to damage synapses, the connections between brain cells, leading to impairments in cognition, focus, and memory. Over time, this process contributes directly to the pathology seen in diseases like Alzheimer's. The irony is, many of these foods are marketed as convenient, harmless, or even healthful. But what we're learning now is that convenience comes at a price, paid in slow, incremental brain decline that often goes unnoticed for years. People begin to experience brain fog, difficulty recalling names, misplacing items, and eventually, more severe cognitive changes that interfere with daily living. The key takeaway is this: ultra-processed foods don't just impact waistlines or cholesterol numbers, they impact the very structure and function of the brain. And for many, the early stages of dementia may be triggered not by age alone, but by decades of silent damage inflicted one processed meal at a time. Recognizing this connection gives us an opportunity, a window to intervene before the decline becomes irreversible. When we talk about energy metabolism in the brain, one molecule stands at the center of it all: insulin. Most people associate insulin only with blood sugar and diabetes, but it's far more than that. Insulin is also a powerful signaling hormone in the brain. It helps neurons absorb glucose, maintain synaptic plasticity, and regulate neurotransmitter function. In other words, it supports memory, cognition, and the overall health of your brain cells. And when this system breaks down, when the brain becomes resistant to insulin's effects, we start to see the early signs of neurodegeneration. The condition we call insulin resistance is typically known for affecting muscle, fat, and liver cells. But brain cells, particularly in areas like the hippocampus and cerebral cortex, are also insulin sensitive. These areas are critical for learning, memory, and executive function. When the brain becomes insulin resistant, it struggles to take up glucose effectively, which is its primary source of energy. Think of it like a fuel shortage. Neurons are starving in the middle of an energy crisis, even when there's plenty of glucose circulating in the blood. This metabolic dysfunction doesn't just slow things down. It leads to direct structural damage. One of the earliest changes observed in Alzheimer's disease is reduced glucose metabolism in the brain. PET scans show areas that go dark, regions that are no longer able to utilize glucose properly. And that's not just a symptom, it's a warning sign. The dysfunction appears years, even decades before a clinical diagnosis is made. Over time, this inability to process glucose contributes to the accumulation of harmful proteins like amyloid, beta, and tau. When insulin signaling is impaired, the brain can't regulate these proteins effectively, allowing them to misfold and clump together. This disrupts communication between neurons, leading to the cognitive deficits we associate with dementia. Compounding the problem is that high insulin levels, common in people with insulin resistance, can suppress a crucial enzyme called insulin-degrading enzyme. This enzyme not only breaks down insulin, but also helps clear amyloid beta. So, when insulin levels remain high, amyloid clearance slows down, further increasing the brain's toxic burden. We're learning that insulin resistance isn't confined to those with diabetes. Even people with normal blood sugar levels can have brain insulin resistance, and they may not feel any symptoms until it's too late. That's why prevention is so vital. Diets rich in whole, unprocessed foods help maintain insulin sensitivity. Physical activity, quality sleep, and fasting protocols can also enhance how the brain responds to insulin. There's a growing consensus in the medical literature that Alzheimer's disease has a metabolic root. Some researchers have even proposed renaming it type 3 diabetes because of how strongly it is linked to disrupted insulin signaling in the brain. This reframing gives us hope. If metabolic health plays a central role in cognitive decline, then improving metabolism could also preserve and protect brain function. And that means the path to a sharper mind may begin not in the pharmacy but on the plate. Inflammation is a term most often associated with joint pain, infections, or autoimmune diseases, but its role in neurodegeneration is one of the most critical and underappreciated aspects of brain health. In particular, the chronic, low-grade inflammation caused by a modern diet rich in processed seed oils and refined carbohydrates acts like a slow, burning fire in the brain, subtle, persistent, and deeply destructive. This is not the acute inflammation that helps heal a cut or fight off a virus. This is a quiet storm brewing in the background, gradually eroding the structural and functional integrity of neurons. One of the major dietary contributors to this problem is the group of oils extracted from seeds like soybean, corn, safflower, sunflower, and canola. These oils are highly processed, often bleached and deodorized, and rich in omega-6 fatty acids. While omega-6 fats are not inherently harmful in small, balanced amounts, their excessive intake, especially in the absence of sufficient omega-3s, shifts the body toward a pro-inflammatory state. The reason lies in how these fats are metabolized. Omega-6 fatty acids are converted into arachidonic acid, which is a precursor to several pro-inflammatory compounds. When consumed in large amounts over time, they can fuel inflammation systemically, including in the brain. This inflammation doesn't just float around harmlessly. It activates the brain's immune cells, called microglia. These cells are essential for cleaning up damaged neurons and responding to threats. But when chronically activated, often due to dietary inflammation, they begin to release cytokines and other chemical messengers that damage nearby brain tissue. Instead of protecting the brain, they become part of the problem, pruning healthy synapses and degrading the integrity of the neural network. Oxidative stress also plays a key role. Many of the polyunsaturated fats found in seed oils are highly unstable and prone to oxidation, especially when exposed to heat. When these oxidized fats enter the bloodstream and cross the blood-brain barrier, they create reactive oxygen species, essentially molecular shrapnel that damages DNA, proteins, and cell membranes in neurons. Over time, this kind of damage accumulates and contributes to the classic hallmarks of neurodegeneration. What's alarming is that this entire process can unfold silently. You won't feel inflammation in your brain. There's no immediate feedback like a headache or fever. Instead, the signs emerge slowly: brain fog, forgetfulness, difficulty concentrating, subtle changes in mood and cognition. These early signs are often brushed off as aging, stress, or lack of sleep, but they may actually be the early manifestations of a brain under attack. Reversing or preventing this process requires a shift away from inflammatory inputs. Replacing seed oils with more stable, anti-inflammatory fats like extra virgin olive oil, avocado oil, and omega-3 rich foods helps restore balance. Eating a diet rich in antioxidants, fiber, and polyphenols further combats oxidative stress. When inflammation is addressed at its root, Especially through dietary choices, we not only protect the body, we defend the brain from premature aging and degeneration. There's a dangerous myth surrounding dementia, that it's something that just happens to people in old age, a natural and unavoidable part of growing older. But emerging research tells a very different story. The brain doesn't suddenly begin to fail at 75. In most cases, the seeds of cognitive decline are planted decades earlier, often as early as your 30s or even your 20s, and they grow silently for years before symptoms appear. This is a slow, progressive process shaped by daily habits, especially those involving food, activity, sleep, and stress. And perhaps most concerning of all, many of the earliest changes in brain health are completely asymptomatic. Neurodegeneration begins subtly. It may start with metabolic changes, such as elevated fasting insulin or reduced glucose utilization in the brain, that don't yet show up as full-blown diabetes or memory loss. These early shifts can precede the visible signs of dementia by 10 to 20 years. One of the first areas affected is the hippocampus, which is crucial for forming new memories. PET scans have revealed that even middle-aged adults with no cognitive complaints can already exhibit reduced glucose metabolism in this brain region. These findings tell us that the process is insidious, developing long before a diagnosis is made. What drives this early decline? One of the major factors is chronic exposure to high glycemic, ultra-processed foods. These foods don't just provide excess calories, they fundamentally disrupt how the body and brain process energy. Repeated blood sugar spikes, followed by insulin surges, set the stage for insulin resistance, not just in the body, but in the brain. Over time, this leads to decreased glucose uptake by neurons, meaning the brain's primary energy source becomes less available. This creates an energy deficit, leaving brain cells vulnerable and functionally impaired. In addition, years of exposure to inflammatory seed oils and environmental toxins can trigger low-level inflammation in the brain, which goes unchecked for decades. By the time someone begins to experience forgetfulness or confusion, the underlying damage may already be extensive. Synapses may be lost, neuronal networks disrupted, and brain volume reduced, all changes that could have been mitigated with earlier lifestyle interventions. That's why prevention has to start early. It's not just about what you do at 70, it's about what you did at 40 and 30 and even younger. Consistently choosing nutrient-dense foods, minimizing processed carbohydrates, avoiding harmful fats, getting restorative sleep, moving the body daily, and managing stress are foundational strategies that preserve cognitive health over the long term. It's a cumulative effect, both for good and for harm. The earlier the intervention, the better the outcome. Every healthy habit you build now is like a deposit into your brain's future, preserving the clarity, memory, and independence that so many people tragically lose. Cognitive decline doesn't begin when memory fails, it begins years before. The key is to act long before the damage becomes visible. When it comes to protecting brain health and preventing cognitive decline, the quality of the food we consume matters just as much, if not more, than the number of calories or macronutrient ratios. Whole, nutrient-dense foods play a central role in maintaining the structural and functional integrity of the brain, and they do this by reducing inflammation, supporting neurotransmitter balance, improving metabolic efficiency, and protecting neurons from oxidative damage. Unlike ultra-processed foods, which deplete the body and brain over time, whole foods nourish at the cellular level, helping preserve cognition, memory, and mental clarity throughout life. Leafy greens like spinach, kale, and arugula are rich in folate, vitamin K, and lutein, nutrients that have been strongly associated with slower cognitive decline. These compounds help reduce homocysteine levels, an amino acid that, when elevated, has been linked to increased risk of Alzheimer's disease. They also support methylation, a key process in DNA repair and neurotransmitter production. Just 1 to 2 servings of these vegetables daily has been associated with significantly younger cognitive performance, even in older adults. Berries, especially blueberries, are another brain protective food. Packed with flavonoids and polyphenols, berries help to reduce oxidative stress and inflammation, two of the primary drivers of neurodegeneration. They've been shown to improve memory and cognitive performance in both younger individuals and the elderly. The mechanisms include improved neuronal signaling, enhanced plasticity, and even increased brain-derived neurotrophic factors, BDNF, which supports the growth and maintenance of healthy neurons. Omega-3 fatty acids, particularly DHA and EPA found in fatty fish like salmon, mackerel, and sardines, are crucial for maintaining the fluidity of neuronal membranes. DHA in particular is a primary structural component of the brain and retina. Low levels of DHA are consistently associated with increased risk of cognitive decline and brain atrophy. These fats also have potent anti-inflammatory effects and have been shown to improve mood, reduce anxiety, and enhance cognitive function across the lifespan. For individuals who don't consume fish, algae-based supplements can provide a plant-based alternative source of DHA. Nuts and seeds, especially walnuts, flax seeds, and chia seeds, provide not only plant-based omega-3s but also antioxidants, vitamin E, and magnesium. Vitamin E has been shown to delay the progression of Alzheimer's disease by protecting neurons from oxidative damage. Magnesium, meanwhile, supports synaptic plasticity and energy metabolism in the brain. Olive oil, especially extra virgin olive oil, is another cornerstone of a brain-supportive diet. Rich in monounsaturated fats and phenolic compounds, it combats inflammation and supports cardiovascular health, which is intimately tied to brain function. The brain relies on steady blood flow for nutrient and oxygen delivery, and a healthy vascular system helps reduce the risk of stroke and vascular dementia. Together, these foods form the foundation of dietary patterns like the Mediterranean and MIND diets, both of which have been consistently linked to better cognitive outcomes. Rather than focusing on isolated nutrients or magic pills, the answer lies in building meals around these protective foods day after day. This simple, consistent approach not only fuels the body, it safeguards the brain. There is a prevailing belief that dementia is simply a genetic destiny, that if it runs in the family, there's little that can be done to stop it. While genetics can play a role in predisposing someone to cognitive decline, the overwhelming weight of current evidence shows that lifestyle is the dominant force shaping brain health. In fact, up to 40% of dementia cases may be preventable with lifestyle modification. This reframes the entire discussion, not from inevitability, but from opportunity. What this means is that we have more control over our brain's future than most people realize. The brain is a dynamic organ, capable of regeneration, adaptation, and repair throughout life. Neuroplasticity, the brain's ability to form new connections and strengthen existing ones, doesn't disappear with age. It depends largely on the inputs we provide. Every bite we take, every night of restful sleep we get, every walk, every stress-relieving breath, these small actions either build cognitive resilience or accelerate decline. Dementia is often the result of chronic, cumulative injury, metabolic, inflammatory, oxidative, all of which are heavily influenced by diet, movement, sleep, and stress. One of the most empowering aspects of this understanding is that even people who have early signs of cognitive decline can slow, or in some cases reverse it through intervention. Diet plays a central role. Avoiding ultra-processed foods and adopting a pattern of eating rich in vegetables, healthy fats, fiber, and polyphenols can dramatically lower inflammation and support insulin sensitivity in the brain. Regular physical activity increases blood flow to the brain and boosts production of brain-derived neurotrophic factor, BDNF, a key molecule involved in learning and memory. Sleep, often neglected, allows for the clearing of metabolic waste products, including amyloid beta. Chronic sleep deprivation, on the other hand, has been linked to an increased risk of Alzheimer's. Stress also exerts a powerful influence. Chronic stress elevates cortisol, a hormone that in high levels can damage the hippocampus over time. Mindfulness practices, social connection, and even simple acts like spending time in nature can help reduce the neurotoxic effects of stress and support long-term brain health. What's important to recognize is that these aren't isolated strategies, they are synergistic. Diet improves sleep, sleep improves metabolism, exercise enhances mood, reduced stress improves immune function. The body and brain function as an interconnected system, and when we support one part, we benefit the whole. This doesn't mean that everyone will be able to avoid dementia entirely, but it does mean that the risk can be meaningfully reduced and the onset delayed. Quality of life can be preserved for more years, and for many people, that means the difference between living with clarity, independence, and dignity or losing pieces of themselves far too soon. Ultimately, the message is one of hope. We are not passive observers of our fate. The science is clear. Dementia is not predetermined. It is often preventable. And the choices we make today can protect the mind we hope to keep tomorrow.